Welcome to Spring LIB.
Hello everyone, today we're doing chapter 18, problem 74, and this problem gives us the starting material reacting with two equivalents of this molecule to give us BHT, and it gives us the NMR spectra of BHT, and it asks us to predict the structure of BHT and then draw the stepwise mechanism illustrating how it's formed. So right off the bat, we can tell that we're going to have some sort of electrophilic aromatic substitution occurring. And we know that this alcohol is directing ortho, but then this methyl group is also directing ortho, but the alcohol is a stronger director than the methyl group, so we're only going to focus on these ortho positions of this alcohol. And we know that through the NMR data that's given that we have 18 singlets, and the only way that we can have 18 singlets is if the carbocation on this electrophile was formed on this carbon, and then 3, 6, 9 carbons would give us a singlet on each side, and then because we would attack on both sides because of the two equivalents of this molecule, we would have 9 times 2, so 18 carbons, which would be the singlet. So then the structure would look something like this. So methyl alcohol would stay the same, but then we'd have our substitution that looks like this. And we can confirm this because on top of that, we would have the 3 protons here acting as a singlet, 1 proton here acting as a singlet, 2 protons here, and that would be all the protons on this molecule. So a stepwise mechanism to get to this is, well, just like every other electrophilic aromatic substitution, we need to first generate our electrophile. So we will use this molecule plus a strong acid, and using the pi bond, we're going to pick up one of those protons to this carbon nucleus, making a bond, and we break a bond. Now we form our conjugate base. We get tertiary carbocation plus HSO4 minus. And then we take our benzene ring, act as a nucleophile to pick up one equivalent of this molecule. And in the process, we're going to get an interior carbocation being formed right here. But then the conjugate base comes in and will reform the acid because the acid catalyzed reaction, so the acid's always reformed, and it's going to pick up this proton to regenerate aromaticity in our benzene ring. And now the same whole reaction set is going to go to now add this carbocation intermediate. Now on this carbon, the acid is going to pick up this proton to neutralize this. So at the end of it, we're going to have a repeating of these exact same steps that we did, but just now on this carbon. And then we're going to form our final product of interest.